Okay, hi. Thank you all for coming to see my talk. Metadata piggybacking, a look into Open Graph abuse. So who am I? This is my first talk at a conference. I'm soon to be a junior security consultant at NCC Group. I start on Monday, so it's an exciting time. And I've also done a lot with the cybersecurity challenge, part of the Team UK, and we're competing in Bucharest in October. So what is Open Graph? So the definition, the Open Graph protocol is simply a method of including meta information in a web page to allow Facebook to accurately represent the page's content when it is linked to in Facebook. Essentially, if you've ever sent a link on a social media platform and it kind of turns that link into more of a sort of pretty kind of object that you can look at, this is the Open Graph protocol. So its history, it was first introduced in 2010. It was created by Facebook for Facebook to do this, but now it's widely used by most social media outlets. So Twitter, Discord, like any sort of application where you can send a link will most likely use the Open Graph. Some applications have developed their own versions. For example, you can use Twitter cards, and this will create these kind of objects specifically for certain applications. So its purpose, it allows a social media platform to create an aesthetically pleasing kind of object. So instead of sending a raw hyperlink, you can send something that kind of you can look at. It looks a bit better on the application, but it also gives you an insight into the information that the page you'll visit, sort of the information that's on it, and sort of what content might be displayed. So how it works. So in your HTML, you'll have your head tags. Within these head tags, you can put these metadata tags. And if you set the property to one of the Open Graph property tags, which is OG title, OG URL, OG description, there are a few more which you can use to begin to customize these. And then what happens is you have a parser. When you post a link on the social media platform, the parser will crawl your page, look for these meta property tags, and then it will create the object based off of these tags that are there. So here you can see, so this is your HTML, and then within that you have the meta property tags. So you've got all of these, which are all tags which can be used in a metadata object, in an Open Graph object. And interesting, on this particular example, you can also see the Twitter cards, which I mentioned as well. And that's how it looks within the HTML. So how it looks, so on Facebook, for instance, once you post one of these Open Graph objects, or once you post a link, it will come up like this. So this is BSidesMCR. So you have, from the metadata tags, you have OG image, which is the big image that you can see. You then have a title, a description, and you can also customize it in a few other ways as well. But this is the sort of basic kind of Open Graph object and how it works. So the parsers, so different applications will have different parsers. So when you post a link, a bot will crawl your website, and it will it will find the tags which it's going to use for the Open Graph object. So here, Facebook, you can determine these using the user agent. So Facebook will have Facebook external hit. Twitter is Twitter bot, and then Discord is Discord bot, and the different applications will use different bots. So what you can begin to do as well is, if you have a website and you want to see who's speaking about your website, so you can begin to sort of footprint which sites your website is being posted on, based on the user agent of the bots that will then crawl your website. So abusing the parser. So we want to look into abusing this and how we can sort of control these objects. So we've got these traditional spoofing methods. So since these objects are basically created from the HTML code on a website, there's nothing stopping you basically ripping the tags from one website and putting them on your own, and then creating your own object of that particular website. So for example here, we have BSidesMCR, and then the metadata property tags that are there. And then I've put them on my own website, reversehex.info/spoof.php. And you can see that the object that's been created is pretty much the same. However, apart from this sort of URL, the object's the same. So this introduced the URL visibility. So what is stopping you from just basically making an object look exactly like sort of one website, and then when you click it, you go to the other website, is this URL visibility. So when you merely just rip the metadata from one site and put it on your own, you have this, which is stopping this kind of spoofing. And it's this string of text that kind of stops that. So, introducing metadata piggybacking. So what if we can actually control that URL visibility in order to, so that we can create a open graph object which looks like exactly like one website, but when you click it, it will redirect elsewhere. And the idea of piggybacking is that I got it from when you do Wi-Fi piggybacking, this is kind of using someone else's Wi-Fi. You're not necessarily stealing anything from anyone else, you're just using it. And that's why I've sort of used the term piggybacking, because with this, we're going to be using someone else's metadata tags, but we're not actually going to be taking them and putting them anywhere else. It's just a case of redirecting to them. So just a quick look at a few parser issues or functionality. Often these parsers will follow redirects. So this is probably for the reason that if you post a link to a site over HTTP, it most likely redirects to HTTPS. So the parser will follow that redirect because it wants to parse the source code and not just a page which has the 301 redirect on. But then what it will do is it will set the URL visibility in the object to the place that it finally reached. So if it follows a redirect chain, it will then put the URL that it reaches at the end of the redirect in the object, which is fine. However, if we combine this with the fact that Open Graph objects are often cached in applications, so to avoid overworking sort of these processes, the web application will cache the object so that if one person sends a link to Twitter, for example, or a Twitter post, and then another person sends a link to the same Twitter post, and this, you know, and lots of people are talking about this particular Twitter post, then you're not going to have a bot which keeps hitting Twitter. You'll have done it once, and then it will reach into the cache for this object. However, when you combine these two things together, it creates a kind of issue. So what it allows us to do is it allows us to create these malicious objects. So here you've got an open graph object of BSidesManchester. However, essentially once you click it, you're capable of changing where it goes to so that it will redirect to a malicious site. So the process of doing this is fairly easy and straightforward. First, we create a web page which redirects to the site, that target site. So if we're trying to mimic, for example, Facebook, I just set a redirect to Facebook on my website. So then when the bot crawls my website, it follows the redirect and passes the HTML, the tags for Facebook. We then post a link onto the social media platform, and the bot will crawl this and it will create the Open Graph object. And then all we need to do is simply change the redirect. So now instead of redirecting to Facebook, it redirects elsewhere. So that because the Open Graph object is cached, when a user then sees that Open Graph object, they're going to see that it looks like it redirects to Facebook, but actually it will redirect elsewhere. So this is what the final result looks like. So here, for example, I've got a link to a YouTube video, and when you click the information, it comes up. So everything about this particular Open Graph object appears to be redirecting to YouTube. And you can see that the URL visibility as well is saying youtube.com, except once you actually visit the link, it goes elsewhere and you've been hacked. So this works cross-platform as well. The Open Graph object is the Open Graph protocol has been designed to work cross-platform, and that means this attack also works. However, on certain mobile applications, sometimes if you have a YouTube video, it'll open it in the YouTube app, but other times it'll work as I've just demonstrated. So gaining trust. So the problem with this is that these Open Graph objects are generated server-side. So as a user, you know that that object's been generated by the application, and therefore you're more likely to trust that link and trust where it's saying the link is going to go to. And because of the URL visibility, which comes up and you're like, okay, that's the final destination, it kind of legitimizes the link that you're visiting. And if we can control that URL visibility, like I've demonstrated, then it's kind of difficult because the user now has the trust of the application and where it's going. And then if you take them elsewhere, they're less likely to check that they're actually being taken to a website, which is the website in the Open Graph object. So why is this an issue? So if a user implicitly trusts the link they're visiting, then you can deliver malicious content and phishing. You can also use the object as an aid to the engineering process because it looks exactly how so if you are targeting Facebook, for instance, in a phishing campaign, it looks like that link that is a Facebook link, is a link to Facebook. So then you can use that in your social engineering. And you can also use this to bypass certain controls. So you've got link filters for phishing. And then using this Open Graph redirect, because you're not initially sending the link to the phishing site straight away, but instead it caches it and then you change the redirect to then redirect to the phishing site, you can bypass link filters of this sort. Okay, so who is affected? So if we just have a look at which applications are affected by this issue, and this sort of brings up a few different ways that the applications are dealing with it. However, it appears that with this sort of quite minor thing, a lot of applications seem to be vulnerable. So for Discord, it creates an Open Graph object. However, with Discord, there isn't a URL visible in the Open Graph object. So when you send a link, it creates an Open Graph object, but within that object, you have no URL visibility. However, with Discord, you can't send only the Open Graph object. You have to send the hyperlink as well as the Open Graph object, which means that the user can always see the exact link that they are actually visiting. Facebook, you can send an Open Graph object. The URL visibility is of the final destination after a redirect, which means you can do you can change where it looks like it's going to, and then it also sends only the Open Graph object. Slack's interesting because you can send an Open Graph object. It shows the URL visibility after the redirect. However, with Slack, you have to send the hyperlink, the message, the link that it's going to initially. However, if you just go back and edit the message, then you no longer need to send the message and the Open Graph object will remain on the platform. And Twitter and LinkedIn are similar to Facebook in the sense that you can send an Open Graph object, you have the URL visibility, and you can also send only an Open Graph object. So just a few examples. So you've got Discord. So here you can see that the top one is the legitimate link to BSidesManchester, and then the bottom one is my evil.php. And you can see that the Open Graph object that's created is exactly the same. However, you have to send the hyperlink alongside the Open Graph object. Facebook, again, here there's no difference between the two Open Graph objects. However, one of them redirects to a malicious page and the other doesn't. Slack, here's the example of Slack. So on the left, you have the original link to BSidesManchester, and then on the right, on the top, you have the original message that you send, and you have to send the hyperlink alongside it. However, then if you just edit the message, you no longer have the hyperlink, and the Open Graph object has the URL visibility of BSidesManchester, yet it redirects elsewhere. Again, Twitter, similar to Facebook, the Open Graph objects are exactly the same. And finally, LinkedIn, the Open Graph objects, again, are the same here. I thought I'd put this in because it threw me off when I was doing this and creating these Open Graph objects. When I first posted the BSidesManchester link, it came up with the Open Graph object for BSidesManchester 2017, which was interesting, and I just thought I'd use it as a demonstration of the caching. So up until that point, if you posted a link to the BSidesManchester page, it would always have come up with that particular object, even though the actual content and the Open Graph object that should have been created was this one. So often the impact of this doesn't necessarily affect the vendor themselves, but it's the sort of their users' data that's at risk. So if it's that their users and are being attacked, and it's their email that an attacker is trying to get, then it's actually the vendor's application is the sort of delivery method, and because it creates these open graph objects and you control the URL visibility, they can gain trust quite easily. However, if it's being used to bypass link filters, this is when it affects the vendor. So I'll go through a quick use case. So the technique would most likely be used to deliver a phishing campaign. However, it can also be used to sort of bypass link filters, as I've said. So meet Rongo98. This is a Twitter account who absolutely loves The Guardian. All down their Twitter feed are links to The Guardian. And if we take one, so this is, are you enjoying your city break, theguardian.com. If we look at the redirect chain for this, you can see that it goes from sort of Twitter's URL shortening to rebrand.ly, to another sort of Twitter shortened link, and then finally to Blissfulfania and blah, 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 which certainly isn't The Guardian. And what they've done here is they've used the service rebrand.ly to set a redirect first to The Guardian site, and then post the link on Twitter, and then afterwards they've then changed the redirect so that it now redirects to this link instead. And rebrand.ly is a service that basically allows you to shorten URLs, but then you can go in and change where the shortened URL redirects to. Who wants to see what Blissfulfania actually is? So this is what Blissfulfania actually is. So certainly not, are you enjoying your city break, my wife says. So I'll just quickly touch on the industry response. I reported this to both Facebook and Twitter, and both of them have sort of said it's not really critical enough to fix. But my argument is that it's not necessarily affecting you, but your users' data is at risk because the majority of people would see one of these open graph objects and sincerely trust that it's going to redirect them and take them to where the URL visibility says. So some key takeaways. So when it's so easy to create these malicious objects, we need to be sort of have an understanding that just because it's created server-side, it's not necessarily going to take us exactly where we think it's going to take us. And then the impact of this isn't necessarily the platform, which has the issue, because if they're using that platform as a method of delivery, then it's kind of everyone's issue. And the trust we have on these objects is quite a lot. And finally, this technique is being used in the wild. And given that the trust that the user has on the open graph objects, if it was to be used in a phishing campaign, I'd expect it to be kind of extremely, it would be very good, very effective. So I just want to say a few credits. Thank you to Ewan, who let me basically spam him with tons of messages trying this technique out. And also a guy, Dude, I'm a Wizard. There's a ZeroFox blog post about the Open Graph Protocol and abusing it. And I did this research sort of quite a while ago and then came across this blog post, read it, and was like, oh, actually, maybe I should look into it a little bit more, and that's why I'm giving this presentation. So definitely go and check out that blog post if you're interested. And thank you. This is my Twitter tag, Cupcake Ninja, if you want to add me on Twitter. But otherwise, yeah, thank you. And if there's any questions, I will answer them the best I can. Yes, Dan.
So for the redirect stuff, will it only will the parser only follow a redirect if it is like a 301, like moved permanently, or would I be able to like create like some kind of script on the initial redirect to only redirect like a certain user agent? Because then instead of like setting it up as a legitimate page and then waiting for the Open Graph to parse it and then changing it, you could just set it up from the start to be like, right, yeah, just redirect these user agents that we know to be parsers, and then send the other ones to the actual malicious. Would that work, or would that just parse the initial like?
So the question is, can you sort of filter out based on the user agent and redirect given a certain user agent instead of just doing it for all users? Yeah, absolutely. So those different bots have the user agents, and on your server side, you can then filter out based on which user agent, and you can serve legitimate content to a user. And if you want to serve the malicious redirect to create the object to the Facebook bot, for example, yeah, absolutely, you can do that. Yes, Mark.
Yeah, so you showed us that it was affected by big companies like Facebook. And so, of course, it's a big problem, but have you found any ways to essentially detect this and detect that someone is exploiting it? Or have you not really looked into that?
So is the question, how can you detect this?
Yeah, so, how can you detect it?
So, yeah, I guess I found it really difficult to detect it, given the amount of links that are being, from my perspective and seeing the actual, whether it's being used in the wild, that was quite a difficult thing to find, because how would you go about finding links which are actually by nature designed to look like other links? So it's kind of difficult. But in terms of actually fixing the issue, it would be simple enough to just make sure that the URL that is posted by the user is visible either within the Open Graph object, or like Discord does, where they send the URL alongside the Open Graph objects, and then this sort of technique you wouldn't be able to do it anymore. Yeah.
Is there any way you can control the cacheability of these objects on the server side?
Could you control the sort of cacheability?
So make it so that it's only cached a very short time and force the bot to repart it.
So yeah, I expect you can. Facebook, you can actually, there's a part of the Facebook API which allows you to refresh the cache of these objects. So if you've updated your website and you want the cache on Facebook to be refreshed, you can manually go in and request for it to be refreshed. But yeah, absolutely, you could set the time of these Open Graph objects to cache sort of for a shorter amount of time. Yeah, you'd be able to do that. But that's down to the vendor. Okay, well, thank you very much.